Good evening, everyone. So I welcome you all in Sapience Education. For more information, you can visit our website www.sapienceeducation.com. So today I'm here for discussing about mechanical properties of fluids and the basic things. Okay. So from the figure you can understand that we all today I will talk about fluids. What are the made up of fluids? What is the basic structure of the fluids? Okay. So here, see here, fluids, any substance which begins to flow when an external force is applied is called fluid, like gas and liquid. Anywhere, whenever anything will flow, that it means that you are saying, or you know that this is your fluid. Okay. Fluid, the branch of physics deals with the fluid in a rest. For example, when fluid is in a static motion, either in a rest or in a tumbler, so the property and the behavior, study of the property of a behavior when a fluid is at rest is known as hydrostatic fluid. Now, what is hydrodynamic fluid? The branch of physics deals with the fluid in a motion. For example, any fluids like a river water, pipe water, all waters or any liquids are flowing. And when liquids are flowing, it means that it is coming under the hydrodynamic parts. Okay, so I hope you have understood now. Now, next is your pressure. What is pressure? So you know thrust. It is a normal force or force acting on a perpendicular on any surface. For example, there is a surface, and when a force is acting perpendicularly or 90 degree, then it means that this type of force is called thrust. This type of force is called thrust, right? What is pressure? Now, pressure is your force by area or thrust by area. Whenever a thrust is acting per unit area, that is known as pressure. The normal force, that is thrust per unit area. The normal force exerted by a liquid at a rest. So when a liquid is at a rest, and the normal force exerted per unit area of the surface for contact with it is called the hydrostatic pressure. Understood? So pressure basically means force by area, and the unit is your Newton per meter square. And you can also say it as a Pascal. So I hope you have understood now. So this is all about pressure. Pressure is force per unit area, and the force must act perpendicularly anywhere. See here, you can understand from the figure. So this is your surface, and force is acting perpendicularly. So from all area pressures are being applied. Okay. So pressure is basically a force per unit area. I hope you have understood now. Right. Now let's begin for another topic. Now, before that, you need to understand what is Pascal. Pascal is the unit of a pressure, and it is a standard unit of a pressure, and dimension is your m L inverse T minus 2. Okay, so I hope you have got it. Now I am discussing about atmospheric pressure. What is atmospheric pressure? So the force exerted by air column on a unit cross section of area of a sea level is called atmospheric pressure. What do you mean by this? Suppose this is your sea, and air is above the sea. So air air at a height of 1000 kilometer, maybe it is. So the 1000 kilometer height, air is applying a pressure at this sea level, and the force exerted by the air column on a unit cross section, that is all we are talking about pressure. But whole air column, if it is your earth, and earth, see here, let's consider this is your earth, right? And earth has an atmosphere of radius 1000 kilometer. Then the whole air columns has some weight. So at the sea level, the force by area acting on this area is known as atmospheric pressure, because an atmosphere is applying a force, right? So atmosphere is applying a force per unit area, and that is known as atmospheric pressure. Okay. Now one atmospheric pressure is equal to how much? So one atmospheric pressure is equal to 1.01 into 10 to the power 5 Pascal. or we can say that 1.01 bar. Now what is bar? Bar is also a unit of pressure. So 1 bar can be written as 10 power 5 Pascal, right? Okay. So bar is your larger unit. Bar is larger unit. Bar is larger unit. Okay, got it? Now, so this atmospheric pressure you have understood now, Pascal you have understood now. Let's go by basic by basic. I will go basic by basic so that you will able to understand in each and everything in this chapter. Now, what is vacuum pressure? Very important. Vacuum pressure, that is zero pressure. Okay. Normally we know that pressure is force per unit area, but at a vacuum, no air is there. And in a vacuum, no air is there. So if no air is there, it means that the pressure is zero. So vacuum pressure means no pressure is there. Okay. Now what is absolute pressure? The pressure taken reference with the zero or vacuum pressure. So if you go by graphically if you want to understand, then just see here. This is the lowest pressure, that is your pressure is equal to zero at a vacuum level. Now the amount of pressure when measured from this vacuum is known as absolute pressure. Absolute means purely, no any reference or no any hidden pressures are there. So it is only compared from vacuum only. So this is known as absolute pressure. But what is gauge pressure? Pressure difference between absolute pressure and atmospheric pressure. So as soon as you are taking pressure from reference with the atmospheric pressure. For example, now what is happening? Now atmospheric pressure is your 1.2 bar, and your instrument has a pressure of total, actually from vacuum to this is your 5 bar or 5.2 bar. So what is the gauge pressure? Gauge pressure is the difference between the atmospheric pressure. This here, suppose this is your atmospheric pressure and this is your absolute pressure. The difference between this atmospheric pressure and the absolute pressure is known as gauge pressure. So gauge pressure is the difference between absolute pressure and the atmospheric pressure. So gauge pressure, if you want to find a gauge pressure, so go for a subtraction of absolute minus atmospheric pressure, so that you will able to find a gauge pressure. So I hope you have understood vacuum pressure, that is your zero pressure, atmospheric pressure and absolute pressure, as well as gauge pressure. So all this basic you need to understand, right? So let us discuss another topic here. What is absolute pressure? Absolute pressure, this is your absolute pressure, right? This is equal to force by per unit area. This is a force per unit area. So again I am telling you that how you will find absolute pressure. Now see here. If you want to find a pressure at point P, and what you want to find? Absolute pressure. How you will find absolute pressure? Pressure is what? Pressure is your force by area. So what type of force? So here suppose there is a liquid or any fluids are there. So due to its weights, force is acting. So force can be written as mg into h. Okay. So force can be written as only mg. Okay. Here force is what? Mg. Force is your mass into acceleration due to gravity, right? So force is your mg. Okay. So force is your mg. Area is your area of this cross section, that is meter per square, right? So let us consider here force at a point P is weight of the fluid above it, that is mg. Mass, m is the mass of the fluid, g is the acceleration due to gravity, right? And what is density? Density your mass by volume, that is volume of a substance. Okay, V is the volume of a substance. So here from here we can find a mass is equal to volume into density. Okay, So as you know that absolute pressure is equal to mg by area. Okay, here I have already told you that force is what, m into g. Why? Because force is acting due to the weight of the fluid, and area is your, this area, particular area I'm talking about. So this is your absolute pressure. Now you know that density of anything or any fluid, there is equal to mass by volume, where volume is the substance, volume v is the volume of the substance. So from here we can write a mass is equal to volume into density. Now if you want to find the volume of this column, so can you write here volume is equal to area into h, that is the area of this cross section into height h. So in case of volume, you can put here volume is equal to area into height h into density. So this is the formula of mass. So if you put this formula at a mass, so what will happen? A into h into rho by into g divided by area. So area got cancelled. So finally you have got h rho g or rho g h, whatever you want to write. So whatever you want comfortable write. So from here we have got the relation that absolute pressure, if you want to find pressure, so you need to find a density of the fluid. See here, if you want to find the pressure at a point P at a depth h, so you need density of the fluid which are responsible for that pressure into gravity, acceleration due to gravity, and the height of the column. The more is the height, the more is the pressure. So I hope you have understood how to find absolute pressure, right? So this is what I have also derived here. This is what I have also derived here. So from here you can see here density is equal to mass by volume. Same thing, whatever I have taught you, right? So we can find absolute pressure of this by this relation. So this is very important relation. If you want to find the absolute pressure, so you just need to find rho g h. For example, there is a container and it has a liquid like this. I want a pressure at this point. So what is the height of the liquid column? Suppose 5 meter. And what is the gravity? This is your 10 meter per second square. What is the density? Density is your, suppose, 10 kg per meter cube. So if you want to find a pressure at a point P or anything, or pressure at a point A, so if you want to find pressure at a, so what will be the formula? Rho g h, where rho is your 10, g is your 10, h is your 5 meter. So this is your 500 Pascal, right? So this is the best method how to find a pressure, right? So I hope you have understood this now. Okay. Now gauge pressure. If you want gauge pressure, just you subtract absolute pressure. Just now you have found out absolute pressure minus atmospheric pressure. So this is a very important relation. Okay. Now what is density? It is a mass per unit volume of any substance. Mass by volume. Density is your mass by volume. That is, mass is kg. Volume is your meter cube. So kg per meter cube is the unit of density. Okay. Unit of density. Right. That is equal to kg per meter cube. You can also write here gram per centimeter cube also. This is your SI unit and this is your CGS unit. Now next topic is your relative density. What is relative? So whenever we want to talk about the word relative means what? Comparison. So it is defined as the ratio of density of the given liquid to the density of the water at 4 degrees Celsius. So this is the formula of relative density. Okay. So relative density means what? Again you tell me. Relative density means density of given liquid. For example, there is a given liquid or kerosene oil is there and it has density, suppose 10,000 kg per meter cube, or it may be 500 kg per meter cube. It has density, and you know that 1000 kg per meter cube is the density for water. So we always try to compare any density with the water, then we get the relative density. So from here, relative density is your density of the substance, that is equal to 500 kg per meter cube divided by 1000 kg per meter cube. So this is your 0.5. This is your 0.5. Now it is your unitless because kg meter per cube, kg meter cube you can cut down. So it has no unit, and it is your scalar quantity. It is your scalar quantity. Okay. So I hope you have understood now this topic. So relative density is now clear cut. Okay. Clearly you can understand relative density, right? Now go for pressure measuring device. This is very important. Pressure measuring device. What is the pressure measuring device? There is a need to find a pressure everywhere, at an atmosphere, at a height h, wherever you want. So before that, I want to find the pressure of an atmosphere. So how you will find? So I will use a barometer, a simple atmospheric measuring device. Very simple. Just no need of any complicated instrument. It is used to measure the atmospheric pressure. A long glass tube closed at one end. See here, closed at one end. It means that one side it is closed. So from here you can see that it is your closed, and filled with the mercury inverted into the trough of a mercury. See here, this is your mercury, and this part is also mercury. Okay. Now what is happening here? As soon as atmosphere is giving a pressure, so this liquid won't come down. It will create some of the height. Now suppose if atmospheric pressure will increase, then what will happen? If atmospheric pressure will increase, then what will happen? Liquid will rise. And as atmospheric pressure is reduced, so what will happen? Liquid column will fall down. So from this we can compare actually the atmospheric pressure, and we can say that here at low atmospheric zone is there or high atmosphere zone is there. Okay. Now the space around a mercury column contains a Hg space above a mercury column. See here, this is your above case where you can say mercury vapor. Approximately you can consider this pressure is as a zero pressure. Okay. Now can you tell me now the pressure at a point B is equal to pressure at a point C, right? So if you get pressure at a B, then it means that you are getting pressure at a C. Now you know that pressure at a C is your atmospheric pressure. So can we write here P atmospheric pressure is equal to pressure at B? And how you will find pressure at B? So by using this technique, simple technique, just now I have told you, if you want to find absolute pressure, just you do this rho G into H, where rho is the density of the liquid, G is the gravity, and H is the height. Now by using this, you will get pressure at a B. And as you have told that pressure at B is equal to atmospheric pressure, that is pressure at a C. So hence we can say that atmospheric pressure, P atmospheric pressure is equal to rho into H into G. Rho GH. What is rho GH? H is the height of the liquid column. Whenever I am talking about height, so it is the height of the liquid column. Height of the liquid column. Height of liquid column. Okay. Liquid column. Now if you increase the height of the so no, we can't increase automatically. If it is rising, it means that we will say that there is high atmospheric pressure is there. Now as soon as this liquid is coming down, what will happen? We can feel that atmospheric pressure is less. So by using this basic formula, you can find atmospheric pressure with the simple barometer. It is your simple barometer. I hope you have got this. Okay. So you know how to now find by using a simple barometer. You can easily find atmospheric pressure, right? Now let's go for a YouTube manometer. What is YouTube manometer? It is a pressure measuring device basically used to measure the pressure difference. So basically we use to a pressure difference. So what is YouTube manometer? See here. It is just a simple YouTube like this structure. Okay, YouTube like this structure. Okay. Now in this what happened? We are filling some of the liquid like mercury or any liquid we can find out. Now suppose there is a pipe. So if you want to connect this this gauge like this, so what will happen? It will, see here. So it means when you connect the pipe, so what will happen? So this is your pipe zone. So as you connect, so what happen? Earlier, before connecting, this was the level. See here, level was same, because at this there is a pressure at this side and pressure at this side will be same. That is atmospheric pressure is there, right? Again, I'm telling you. Again, please try to understand here. See here. Suppose this is your YouTube manometer. YouTube. Uh, Correct it. See. There is a YouTube manometer, right? Like this, right? Okay. Now tell me, if you pour a liquid, so before connecting to this pipe, so liquid will be like this, same level, there is no difference. Why? Because there is also atmospheric pressure, and from this side also there is atmospheric pressure, so the level of the pressure, level of the liquid will be same. But as soon as you connect this thing with the pipe, so what will happen? Pipe suppose has a high pressure, pipe has high pressure. So if it will be at a high pressure, so what will happen? It will try to push the liquid, and due to this, what will happen? This side liquid will rise, and this side liquid will rise till there is a balance pressure balance. So from this, what we can see here? See here, pressure at P or A or B will be same. We don't consider too much difference. Okay, we actually need pressure at a P. Okay, or can we write here pressure at A or pressure at A or pressure at P, both are same. Okay, pressure in a pipe is equal to pressure at A. So can we write here pressure at A is equal to pressure at B, because the liquid of the same horizontal level we have already and I will study that liquid at the same horizontal level have the equal pressure. So as soon as it has same pressure at the same level, so at pressure at a B will be equal to pressure at atmospheric pressure plus rho gs. Why atmospheric pressure? Because here pressure at a B account for addition of atmospheric pressure as well as the pressure due to liquid height. So what is the pressure due to liquid height? So pressure due to liquid height is rho gs, as we have discussed earlier, right? So finally we have got pressure in the pipe P, right? So hence pressure at a gas fluid is measured by just height of the liquid column in the YouTube. So if you get a height of the height in the liquid column, so you will get to know these things like this. So I hope you have understood this section. Okay, how to find pressure with the help of YouTube manometer. Okay. Now since pressure at A is equal to atmospheric pressure is equal to rho gh. Now if you want gauge pressure, so you know that gauge pressure is equal to absolute pressure minus absolute pressure or minus atmospheric pressure. So here absolute pressure at A minus atmospheric pressure will be equal to rho gh, and this is called gauge pressure. So if you are using manometer, then you can just by using height rho gh, you can just say that this is your gauge pressure, not absolute pressure. Gauge pressure. In YouTube manometer, if you have a height h and you have a liquid density rho, then you just find out the pressure like rho g into h, and this pressure is known as gauge pressure. This pressure is known as gauge pressure, because gauge pressure is the difference between actual pressure and atmospheric pressure. So I hope you have understood these things, right? So you have understood now how to find the gauge pressure and all. And if you have any query regarding this, so please ask me. Feel free to talk with me. Okay, and ask and comment in the comment section. Okay. So I hope you have understood. It is really good for me that you have attended my class. Thank you for attending my class. And if you have any type of problem, please be in a touch. I will make regular videos on the class 11 section. Okay. So thank you everyone for watching my video. Please subscribe our channel.